Hi everyone, how are you all? Dear students, today we are going to discuss about one of the most simple, easy and important topic, that one is applications of trigonometry. The topic is applications of trigonometry. Means in this chapter we are going to apply basic trigonometric ideas, basic trigonometric formulas. Using that we are going to solve heights and distances of the given data. Understood? Right. Let us discuss about it. Now, coming to the introduction of the topic, without giving lagging, we are going to apply trigonometric knowledge for some purpose. For some purpose. So, what is that one? What trigonometric ideas we will apply? For what purpose we will apply? We will discuss. First of all, according to trigonometry, we come across the trigonometric ratios. That one is in a right angle triangle. In a right angle triangle, if inclination is forming, angle is forming here, then this is called as opposite side of this theta angle. This one is called adjacent side of this theta. 90 degrees opposite side is called hypotenuse. Based upon these three sides relating with theta, we will get trigonometric ratios. That one is sin theta is equal to opposite side of theta by hypotenuse. Cos theta is equal to adjacent side of theta by hypotenuse. Tan theta is equal to opposite side of theta by adjacent side of theta. These three trigonometric ratios, basically we will get. Three more are there, those are their reciprocals, but we will not use them particularly in this chapter. We will apply these main. Along with that, we will apply trigonometric ratio table values for some specific angles. If theta is 30 degrees and 45 degrees and 60 degrees, particular specific angles, we will apply sin theta values, cos theta values, tan theta values of these particular angles, such as sin 30 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, whereas cos 30 will become root 3 by 2, cos 45 will become 1 by root 2, cos 60 will become 1 by 2, whereas tan 30 will become 1 by root 3, tan 45 will become 1, and lastly tan 60 will become root 3. These particular specific angles trigonometric ratio values we will apply from trigonometry. For what purpose we will apply? That is the main reason here. The purpose is, whenever there is a right angle triangle, automatically trigonometric introduction comes. If you observe this right angle triangle, automatically it gives some horizontal line and some vertical line joining to give us right angle triangle. So the same principle of right angle triangle in other discussion, if there is an observer here, observer looking at some upper object here, then some inclination will form with normal sight to the line of sight. Then this is called as distance of the observer from the object. This is called height of the object. So when theta is the angle formation in this general condition of observing the upper object, distance height discussion comes under a problem. So whatever the adjacent sides, opposite sides, hypotenuse are there, they are coming as a distance of the observer from the object, height of the object, and this is called line of sight, hypotenuse. Okay, Nana? This one is called line of sight. So, we will apply trigonometry for finding the heights of the objects or distance of the observer from the given data. So, in the olden days, the same topic called as heights and distances. Now it is called as applications of trigonometry for finding height of the objects or distance of the objects depends upon the given data. This is the purpose, right? So, before going to apply this trigonometrical basic applications into this type of utilization, we should come to know two things. Those are angle of elevation, means when the observer is there, automatically he will form some normal site which gives us horizontal line. Particularly if that person is going to observe the upper object like a tree, upper object, then he will change the observation view to look at the upper object. So then some inclination occurs by the change of view. So when he want to observe the upper object, inclination is forming. That inclination is called angle of elevation, which happens to look at the upper objects. When the line of sight is going to observe the upper object than the observer, then from the normal sight to the line of sight, whatever the inclination will be formed, that is called angle of elevation. At the same time, we should observe what is meant by angle of depression. Angle of depression means if the observer is there, automatically he will make some normal sight straightly. If the observer want to look at lower objects, look at the lower objects, object is there here, this is the target. If you want to look at this, so normal sight will come down like this to observe that lower objects. So this is the line of sight according to our requirement. From the normal sight horizontal line, whatever the inclination is making deeply to observe the lower objects is called angle of depression. Angle of depression. So angle of elevation forms when we observe the upper objects. Angle of depression forms when we observe the lower objects. How to utilize them? When the observer is there, you can take vertical things to form the picture properly. Then right angles will form. So automatically the data gives us right angle triangle with angle of elevation or with angle of depression, right? And after knowing these two, we should observe the third point. That one is when two lines are parallel, if there is a transversal line, intersecting the 2 points at 2 distinct points, then this angle theta is called alternate interior angle of this one. Both are equal. Alternate interior angles are equal. Okay, or if it is theta 1, this will become theta 1. So just observe this. If this is the observer making angle of elevation, this angle is called angle of elevation. If this is the observer from the normal side looking down, this is called angle of depression. So applying the transversal property upon parallel lines of horizontals, angle of depression will be equal to angle of elevation in this particular conditions. Okay, Nana? We will apply this concept of angle of depression equal to angle of elevation using this transversal properties to make the problems easy to solve. Understood? Right. Okay. After taking that introduction part, we are entering into the first exercise of applications of trigonometry, that is exercise 12.1. In this, the most important problems are 1, 2, 4, 5, 8. Okay, Nana? Main model problems only we are discussing here without wasting the time. Let us discuss about them. What is the first problem? Matter will be there. Observe that one. Okay. What process we have to apply means, convert the data into diagram. It contains right angle triangle. Give its proper description. What values are given from the data, what value we need to find out, that description we should have to give. That is the second work. For our requirement, using the data, what trigonometric ratios or what trigonometric values we need to apply, write the formulas and simplify them. That's it. 3 steps. Word problem, data to diagram, diagrams description, formula, simplification, getting answer with proper conclusion. That is the process. Let us observe that. What is the first problem? First problem, data contains, the word problem contains, a tower stands vertically on the level ground. Let us consider this is the level ground. A tower stands vertically. AB is the tower stands vertically on the level ground. Okay. Now from a point 15 meters away from the foot of the tower, there is an observer, let it be C, making an angle of elevation. Means from normal side to observe the upper object, whatever the angle will be formed, that is called angle of elevation. So use the arrows for proper understanding. So angle of elevation from the observer to look at the upper top position of the tower is 45 degrees. Then they are asking what is the height of the tower. So in this way, read the data properly, convert it into diagram with proper naming. See, immediately it is clearly giving as a right angle triangle. So we are able to apply applications of trigonometry for our required answer. But give the description for that. Solution: from the data, height of the tower AB is equal to H meters. We need it, let it say. Distance of the observer AC is equal to 15 meters, this one. And angle of elevation, that is ACB, angle ACB is equal to 45 degrees. This is the given data. Diagrams description, second part completed. So to find out the height of the tower, utilize the data. How to utilize the data? My vision is, clearly it is a right angle triangle and the angle is given. For this given angle, the given side is adjacent side. I want opposite side. When I know the angle and one of its related adjacent side, and if I need opposite side, relate the angle and given side and required side. Opposite side I want, adjacent side I have, angle I have. Obviously, I need to apply tan theta formula, which is opposite side of theta by adjacent side of theta. I want opposite side of the theta by knowing adjacent side of the theta and theta value. So that is happening in right angle triangle ACB. Tan theta equal to opposite side of theta by adjacent side of theta. That implies tan 45 degrees is the angle equal to opposite side is AB by adjacent side is AC. That implies tan 45 means 1 is equal to AB value, that is height I want, H. AC 15 is given, cross multiply them. This implies 15 into 1 is 15 equal to H. This is the answer, but conclude it. Therefore, height of the tower is equal to 15 meters. That's it. Now, see the next question, second problem. This model is very important among all. What that question contains? Word problem is displaying there. The question meaning is, there is a tree AB on the level ground. Due to a storm, it is broken somewhere at sea. The upper part is falling down where the top of the tree B touches the ground at B dash by making an angle of elevation with the ground 30 degrees at a distance of 6 meters from the foot of the tower A. That is the data. What they are asking, what is the height of the tree? So we need height of the tree AB, where it is broken at C, the upper part is falling down, making an angle of elevation with the ground is 30 degrees at a distance of 6 meters from the foot of the tower. So to find out AB, it is nothing but AC part plus CB part. Clearly CB part is nothing but CB dash part. Okay. So we want to calculate AC value, CB value, which means AC value, CB dash value. That is our requirement. For that, how to apply the trigonometry? Clearly you see a right angle triangle is formed with 90 degrees at A. At B dash 30 degrees angle is there, elevation, and one of its side 6 meters is given, that is the adjacent side of the given angle. We want opposite side as well as hypotenuse. So after giving the proper description, you try to habituate to write the description here, Nana. Okay, directly I am writing the solution. You see, from right angled triangle, I want to find out opposite side AC using adjacent side. That's why I am going to apply tan 30 degrees is equal to its opposite side AC by its adjacent side AB dash, which implies tan 30 means 1 by root 3 is equal to AC I want by AB dash value 6 meters. Cross multiply. This is 1 by root 3 into 6 can be written as 2 into 3. That 3 can be written as root 3 into root 3 for our convenience equal to AC. Now root 3 get cancelled. Therefore, AC value is coming as 2 root 3. First part of the tree. This is equation 1. Next part CB, which is nothing but CB dash. These both are equal lengths. Okay. So how to find out that? That is the hypotenuse of this right angle triangle. I need hypotenuse using adjacent side. So I want to apply cos theta, which is nothing but adjacent side of theta by hypotenuse. That can be written as cos 30 degrees equal to adjacent side AB dash by hypotenuse CB dash. That implies cos 30 degrees value root 3 by 2 is equal to AB dash is 6 by CB dash value we want. Cross multiply them. This implies CB dash is equal to 6 into root 3 by 2. When it goes to other side will become 2 by root 3. Okay, Nana. Now this implies CB dash is equal to 6 can be written as 2 into root 3 like here into 2 by root 3 get cancelled, finally it gives 2 to the 4 root 3 meters. That is CB dash value 4 root 3 meters. That is the second part of the triangle equation 2. But our required value is therefore height of the tree, which is nothing but AB, that is nothing but AC plus CB, that is nothing but AC plus CB dash. These two are equal parts after falling down. This is equal to AC value, we got it as 2 root 3 plus CB dash value comes as 4 root 3. This is equal to 6 root 3 meters. That's it. Okay, Nana. Now, Seema, we are going to discuss about fourth problem, important one. The data contains the shadow of a 15 meters high pole is 15 root 3 meters. Read the data properly, interpret it correctly. Means 15 meters high pole AB giving a shadow on the level ground AC of 15 root 3 meters. At a time of 8 o'clock in the morning, what is the angle made by the sun rays to make this situation with the level ground? What is the angle made by the sun rays with the level ground? Observe that. Pole is always vertical to the level ground, so 90 degrees will be there. Let us assume this is the sun ray making pole's shadow properly with 15 root 3 meters. That is the data converted into diagram. So clearly right angled triangle is formed. In this we need to find out angle theta between the sun rays and ground. Sometimes they can ask you the angle to find out between sun rays and pole also. So where we need that angle, in which place angle they are asking to find, that is important thing under CC pattern. Since we need this angle, automatically you observe that they had given its opposite side as well as adjacent side. So after knowing opposite side and adjacent side, we are going to apply tan theta from the diagram. That is opposite side AB by adjacent side AC, which implies tan theta required angle equal to AB value 15 by AC value 15 root 3. 15 cancel. This is equal to 1 by root 3. 1 by root 3 comes for tan 30 degrees angle. So tan theta equal to tan 30 degrees means theta is equal to 30 degrees. So angle made by the sun rays, therefore conclusion. Okay, ma. Now observe that the next problem, fifth one, it is also important model only. If you follow the problems, no two problems are same kind. In every problem they are taking a small variation. By using that data we are converting the diagram, applying trigonometry for getting the required answer. Okay, so this one is also having a little variation. What is that one? The data contains they want to erect a pole AB with the help of three ropes to stand it properly on the level ground. By making an angle 30 degrees with the pole. Ropes are making angle 30 degrees with the pole. Then how much length of the rope is needed? BC, BD, BE, all these equal length of 3 ropes to erect the pole, total length we want. They are asking that one. Okay, how to find out that? Let us observe that. For that, there is a level ground. They want to erect a pole AB whose height is 10 meters with the help of 3 equal ropes. But among them, I am considering only one rope which is touching the top of the tower with the level ground. This rope BC is making an angle 30 degrees with the pole, not with the ground, with the pole. That's why where that angle is forming is important. So find the length of this one rope BC, make it into 3 times to get total length of the rope. Okay, this is our aim. For that, clearly pole will be 90 degrees with the level ground. Angle is given. Its adjacent side already we know. We want hypotenuse. So from the right angle triangle, ACB, apply adjacent side we have hypotenuse we want. So cos theta as adjacent side of theta by hypotenuse, which implies cos 30 degrees. Angle is there here is equal to adjacent side 10 by hypotenuse value BC. This implies cos 30 degrees value root 3 by 2 is equal to 10 by BC. Cross multiply them. This implies BC is equal to 10 into 2 by root 3. This is equal to 20 by root 3. To make it proper way, into root 3 by root 3 we can do. This is equal to 20 by 3 into root 3 meters. Okay, Nana? Therefore, BC one rope length equal to 20 by 3 into root 3 meters. Therefore, total length of 3 ropes equal to 3 into each rope length BC, that is equal to 3 into 20 by 3 into root 3, 3 get cancelled, that is equal to 20 root 3 meters. That's it. That is the total length of the 3 ropes which are helpful to erect the pole. Right, Nana? Okay, ma. Now we are taking last important problem of this exercise, 8th one. This one is also having its own speciality. What is that data contains? A boat travels from one bank of a river, place A, to the other bank. When a boat is traveling from one bank of a river to the other bank, remember that with common sense, it will not go straightly because flow of water will be there. They push the boat, so boat comes, travels like this to reach the opposite bank. Like this it comes. This is the direction of the traveling of the boat to reach the opposite side B. While this journey, it is making an angle 60 degrees with the bank and traveling for a distance of 600 meters. Then what is the width of the river from that bank to this bank? What gap is there? That is the width of the river. Let it be C. They are asking BC. So you observe that clearly there will be a right angle triangular shape. So use that data. So from this right angle triangle ACB, we know the angle 60 degrees and its hypotenuse. We want its opposite side. Okay. So obviously we have only one chance, that is sine theta, that is opposite side of theta by hypotenuse using the given data and requirement. This implies sine 60 degrees equal to opposite side BC, that is width of the river, by hypotenuse AB. That implies sine 60 means root 3 upon 2 is equal to BC is width of the river W by AB value 600 meters. Now cross multiply them. This implies root 3 by 2 into 600 is equal to width of the river. 2 ones are 2, 300s are. Therefore, width is equal to 300 into root 3 meters. That's it. This ends the problem. If in these kind of problems, if they mention root 3 value as 1.732, then you should substitute, you should simplify. That is compulsory. Otherwise, you can leave the answer like this, no problem. They will award full marks. Thank you. So, revise them properly, read the data, convert it into diagram, give description. This is compulsory. Write the formulas well, simplify properly, conclude the answer. Easily you will get full marks. Thank you, Nana.